In this video, we're going to talk about angles of polygons. First, we need to remember what a polygon is. A polygon is going to be a closed figure consisting of 3 or more straight line segments. It's a difficult way of just saying it's going to be a enclosed figure with 3 or more sides. Okay, triangle and beyond. Okay, you can't have a polygon with 2 sides because you can't close them in. The next part says we can find the sum of the interior angles of any polygon by connecting a singular vertex point to all other vertices in the shape, creating a series of triangles. What that means here is when we take a look at the triangle, we go to a vertex and we go and we connect each other vertex. We're just going to be going down the sides. So our number of sides is 3. The number of triangles, we just have 1. This will make more sense once we get to the other one. And then our sum of our angles is going to be 180. Okay? So we already know that with triangle sum theorem, all 3 angles add up to 180 degrees. When we have a quadrilateral, 4-sided, we connect vertex to each, and it just goes like this. We just connect the same vertex to all other vertices. We wind up with 2 triangles here. Okay? And the sum is going to be 360 degrees. When we go through these and I give you the sums, I'm just going to give them to you since we have not learned the formula yet. Okay? With the pentagon, we have our 5 sides. Okay? So your number of sides is going to be 5. If we pick any vertex and we go to all the other vertices, we're going to notice that we have 1, 2, 3 triangles. We're going to wind up with 540 degrees as all 5 angles added up together. Our hexagon, we have 6 sides. Again, taking that vertex, 1 to go connecting to each and every other 5 vertices. We're going to end up with 1, 2, 3, 4 triangles. So here's the fun part. We have to start drawing these. Heptagon is going to have 7 sides. So we just draw. It doesn't matter what it looks like. 1, 2, 3, 4, 5, 6, 7. Okay? It doesn't look good. But here, if we go to, let's just say we're going to start at this vertex here. I'm going to connect to each and every other vertice. Here, here, here. Kind of hard to tell where they are. Here, here, and here. We're going to end up with 1, 2, 3, 4, 5 total triangles. This is not the prettiest in the world. And I forgot to give you hexagon up here. Hexagon, sorry about that. It's a total of 720 degrees. Your heptagon will be a total of 900 degrees when you add up all 7 interior angles. Your octagon, we're going to have 8 sides. 1, 2, make it look like a stop sign. 3, 4, 5, 6, 7, 8. I'm really bad at drawing these shapes. If we start just 1 vertex, we're going to connect each other vertex. Here's 1, here's the other one, here's another one, here's another vertex here, another vertex here, another vertex here, and then our last vertex. If your shapes aren't great, don't worry about it. I'm going to be honest with my class, I'm not even going to have them draw the shapes. Okay? This is the last one I'm going to draw because I don't want you to have to do it either. Here we have 1, 2, 3, 4, 5, 6. Sorry, we should have, did I connect all those? 1, 2, 3, 4, 5, 6, 7. We've got a total of 1, 2, 3, 4, 5, 6. Yep, 6 triangles. Octagon has 8 sides. And the total measurement of all the interior angles added together is 1,080. You can see a pattern going on here. Your notagon sides, we're going to have 9. So as you can see with the number of triangles, it keeps increasing by 1. So we're going to end up with 7 triangles drawn inside. Your angle measurements are going to be 1,260. All the angles added together, interior angles. Your decagon is going to be a 10-sided figure. If you follow that pattern, we're going to have 8 triangles. The number of triangles is also going to be 2 less than number of sides, which is going to come in handy here in a minute. And you're going to wind up with 1,440 degrees as all 10 angles added together, whether they're congruent or not. Now, with this, we're going to take the number of sides and the number of triangles. Okay, we're going to notice that there is a 2-number difference. Okay, each one of these, you subtract 2 from the number of sides, and you're going to get the number of triangles. So this is going to be part of our formula, all right, and finding the sum of the interior angles. So here, this is going to be sum of interior angles. So what happens is, when we start off with the first polygon, we have 180 degrees. each time we're seeing this 180 being added. So this 180 is going to be important. All right, that's going to be our starting point of the big thing that's in common with all of our formulas or all of our interior angles. We're going to have this 180 degrees. But we need to see that we have subtracted 2 from the number of sides to get the number of triangles. Basically, it's going to be the number of triangles times 180 degrees. That's what ends up happening here. So we have to take our number of sides, which is represented by the letter N. We have to subtract 2 so that we can get the number of triangles, and then we multiply that by 180, and that's your formula. Okay, so to recap, we take the number of sides, we subtract 2 to get the number of triangles. We take the number of triangles and we multiply it by 180, and this is how many, this is the sum of our interior angles. All right, let's take a look at the next page and look at some examples here and use this formula. So go ahead and set this up. I'm going to go ahead and put the formula up here at the top, 180 n minus 2. Please pause this at any point that you need to, okay? And I encourage you pausing and trying them on your own. We're going to find the sum of interior angles of a 13gon. So what this means is n is going to equal 13. Okay, this is how many sides we have. So we're going to plug in n. If n is 13, we're going to have 180. n, 13, minus 2. So then we end up with 180 times 11. And then we end up with 1,980 degrees total. That's all you're doing for the sum of interior angles. It is that easy. And honestly, in your calculator, if you're careful, you can plug in 180 parentheses, 13 minus 2 in parentheses, and you don't even have to take this baby step here. So now we're going to find the sum of the interior angles of a 1,200 gon. We're going to end up with a very big number here. What this means is n is equal to 1,200. That's a big jump here, okay? So let's just go ahead and plug this in. 180 parentheses, we're going to substitute in for n, 1,200. Not closing the parentheses just yet. Subtract 2. Go ahead and try it on your own. Pause it. Get it on your own. Just plug it in. Okay? We're going to find out this is going to come out to 215,640 degrees. The more sides, the more degrees. Now, this is just any polygon. Now we're going to go into talking about a regular polygon. The regular polygon means you're going to have this polygon, but all sides are congruent now, which means all angles are also congruent. So we can actually figure out how much each angle measurement is, and that's what we're going to do here. Adjusting this formula up here, we're going to find the measurement of each interior angle, and we're going to be using this formula here. So you see that 180 n minus 2 on top. That's finding the sum. And then because each one is exactly the same, they're all congruent, you're going to take that number of sides, which is also the number of angles, and you need to divide it evenly amongst every single angle. So you divide by the number of sides. So you're using n twice here. So we're going to do one where we're going to find each interior angle, and then we're going to work backwards on one and be given the interior angle. First one here, find the measure of each interior angle of a pentagon. Pentagon, even if you look back at the first page, we see that a pentagon has our 5 sides. You need to know your triangle through decagon. So this means n equals 5. So plugging into the formula we have above, the 180, n minus 2 over n. Here's 180. n minus 2, so 5 minus 2, all over that same 5. Okay? When we plug this all into the calculator, you can do it all at once if you'd like to. I know at our school we've got a control divide function that gives us a fraction. We could type all this in. We're going to find out that each interior angle is going to be 108 degrees. Again, this is regular polygon because all angles are congruent. The next one here, we're going to work backwards, okay? If a regular polygon has an interior angle of 150 degrees, so we have the interior angle now. We have this part right here on the formula. We want to know how many sides, so we are actually looking for n. What we need to do first is set up what we have. Okay, we have the interior angle of the formula. It's 150. I'm going to write small because there's going to be quite a bit of work here. We're going to set that equal to, on the top of the numerator, we have 180 n minus 2. All over n. We're looking for n's. A lot of n's, but we're going to go through this one step at a time. The first thing is we need to get rid of that fraction on the right. We need to get rid of that denominator. Since this is dividing, we do the opposite, and we multiply both sides by that n. So that these cancel, and what we have left is just the 180 n minus 2. On the left-hand side, when we have a variable and a number, we just put them together. We're going to put the n on the other side, though, so we have 150 n. Now, we need to get n on the same side, but first we have to do this distribution over here. We have to distribute 180 to n, so here we now have 150 n equals 180 n. Then we distribute that 180 to minus 2, and we get minus 360. I'm going to show you a way that we're going to have negatives first, but it'll all work out in the same. I'm going to move the variable, the 180, over to the left. Okay, so I'm going to subtract this 180n from both sides. It cancels over here on the right. On the left, we need to understand this is going to be a negative 30n. Okay, negative 30n. And what is left over here is a negative 360. Be careful with that. Okay. And then just like if they were positive, we need to divide both sides by what's attached to n, that coefficient, and the n is a negative 30. So whenever we divide negative 360 by negative 30, it cancels out those negatives, and we end up finding out that the number of sides is 12. Okay? Another thing we need to talk about is exterior angles. Your exterior angles of polygons are always going to be 360. Okay, so the sum of exterior angles is always going to be 360, and we'll see this around. We need to remember that. Let's go ahead and take a look at our additional examples that are on the last page of these notes here. We want to find the missing angle. Well, the first thing we need to do is figure out what do they all add up to be? What is the sum of these interior angles? So, to do that, we'll go ahead and get some more pens out, sorry. We're going to go ahead and use our sum of interior angles formula. Here's our sum of interior angles, which was that 180 n minus 2. It's the sum, not each. So we need to figure out how many sides we have. I have 1, 2, 3, 4, 5, 6, 7. So n is going to equal 7. Well, let's plug that in. When we do this, we add it all up, or we could have even looked on the first page right here. We would have found out 7 was 900. We need to practice using that formula. So now we can add all of these up together and set it equal to 900, because we know the sum of all of these, including the missing one, is going to equal that 900. So we just add all these constants. I'm not going to write all these out, but we need to, in the calculator, if we add all these 125 plus 119 plus 117 plus 145 plus 133 plus 140, we're going to wind up with this x plus the sum of all those angles that they gave us would have been 779. And then we set this equal to that sum of 900. And all we're going to do is subtract now. That's it. We subtract that 779. Go ahead and get that. We could find that missing angle there. All right, next we want to find x. So here, it's going to be almost exactly like the previous problem. We just have coefficients and, so we got the variables and constants together. Instead of just numbers, we've got some more algebra work to do here. So the first thing we need to do is we need to find the sum. So we can set it equal to it. The sum, we have 1, 2, 3, 4, 5 sides. So n is 5. We have that 180 in minus 2, so 5 minus 2. We will find out this will be 540 degrees. So we need to set all of these, we need to add all of these together to get to set it equal to 540. So I'm just going to go through, I'm going to find, instead of having to write them all down, I've got a 3x plus a 9x plus a 7x. So I have a total of 19 x's. Now be careful with this. We need to look at our constants. I have a positive 22. I'm going to add this 95. I'm going to subtract this 4. Look, guys. I need to add this 90 degrees. And then lastly, subtract this 6. When we combine all of these like terms together, we're going to wind up with a positive 198. All set equal to the sum 540. We will have 2 steps. Go ahead, pause the video, please. Complete those 2 steps, and then resume. You need to do it on your own. All right, we should have got an 18 with our algebra here. Next problem. Let's take a look here, what we're going to have to do. Now, we need to notice that these congruent signs mean we have a regular polygon. Okay, so right here, we have a regular polygon, which means all the sides are congruent, all the angles are congruent. So instead of finding the sum and adding each one of the, adding it that many times, all we need to do is figure out what each interior angle is, okay, using this formula right here, each interior angle, and set the 16x plus 23 just to that. Okay, these were not regular. All the sides were different. All the angles were different. So here, if we use our formula for each interior, we have our 180 n minus 2 over n. So let's figure out what n is. We got 1, 2, 3, 4, 5, 6, 7, 8. So n is going to be 8. And let's plug that in here. 180, 8 minus 2 over n, 8. We're going to find that the interior angle is equal to 135 degrees. So now all we have to do is take the 16x plus 23. It is also 135, so since they are the same, we set them equal to each other, 135 degrees. Go ahead and pause the video. I'll give you a second to grab that mouse or whatever you need to, tap the screen, pause it, solve for x on your own, please. All right, we should have come up with 7 for x. Good job if you paused and did it on your own. Let's go ahead and take a look at the last problem. So on the previous page, the bottom, we discussed here that the sum of exterior angles is always this magic number 360, no matter how many sides that this polygon has. So now we're going to go ahead and practice this using this guy right here. We've got this magic number 360, so exterior angle equals 3, it's supposed to be an angle symbol, sorry, angle 360 degrees. We're going to add all of these up together, okay, and we're going to set this to 360 degrees. So let's go ahead and add up our variables here. We've got 3 plus 7 plus 4 plus 6. We're going to wind up with a total of 20 x's. Now let's look at our constants. We have a 6 plus a 41 minus 5 plus 7 plus 62 minus 11. When all of this is plugged into the calculator, we're going to wind up with 100, and it's a positive 100. All set to 360 degrees. So again, pause the video. Solve for x. You got 2 steps. That is it, and then resume. The answer is about to pop up. All right, you should have gotten 13 for x. So hopefully this has helped you out with interior angles, sum of interior angles, each interior angle when you have a regular polygon, as well as each exterior angle.